Please look at this example number 30. I guess I had only discussed the first question yesterday. Cos inverse x root 3 plus cos inverse x equal to pi by 2. We'll have a little bit more idea about how to solve these equations. Look at example number 30. Solve for x. They want us to tell them the value of x. And the question is tan inverse x bracket square plus cot inverse x bracket square equal to 5 pi square by 8. So as you all know, a square plus b square can be written as a plus b bracket square minus 2ab. Yes. A square plus b square can be written as a plus b bracket square minus 2ab. Now a plus b is pi by 2. So pi by 2 bracket square minus 2a into b. Now cot inverse x can be written as pi by 2 minus tan inverse x. Yes or no? Cot inverse x can be written as how much? Pi by 2 minus tan inverse x. So pi by 2 bracket square minus 2 into, if you expand this, you will get this equation 2 tan inverse x into pi by 2 minus minus plus 2 tan inverse x bracket square. Yes. So is this a quadratic in tan inverse x? Is it a quadratic in tan inverse x? Yes or no? So can you just solve it by the means of quadratic equation? Yes, can you? So after solving this, tan inverse x, they got it as minus pi by 4 and 3 pi by 4. After solving this quadratic equation, you can simply call tan inverse x as m. This will be 2m square minus pi m minus 3 pi square by 8 equal to 0. And by using the formula method, you can directly solve it. M equal to minus b plus minus under root b square minus 4ac upon 2 into a. Got it, all of you? So accordingly, you'll get two values. Tan inverse x is minus pi by 4 and tan inverse x is 3 pi by 4. For minus pi by 4, you can tell the value. That is minus 1. We have to neglect tan inverse 3 pi by 4. Why is it so? Why tan inverse x equal to 3 pi by 4 should be neglected? Because there is no such value for which the angle happens to be 3 pi by 4, as the principal value branch is strictly minus pi by 2 to plus pi by 2. Could you see that every conclusion is strongly connected to the basic concepts of principal value branch? Because this all part is all algebraic, that you have to just use the formula and get the quadratic, use the formula method, get the two answers. This is not that difficult to do, to get these two angles. After getting these two angles, you need the basic concepts clear to conclude that which angle should be considered and which should be neglected. So minus 5 by 4 could be considered, so x will be equal to minus 4. Now this kind of question, the subjective question, why I do not ask you to solve this, because in this kind of question you would be having 4 options, and simply by taking x equal to minus 1 from the option, you can check whether the equation gets satisfied or not. Okay, so this is kind of, this would be a simple question if it is asked in the MCQ manner. But anyways, did you get the concept? You had such kind of question in your MCQ test, I guess. Arc tan x and arc cos y. You had seen this once. They haven't specified this as a different point, but you can see, determine the integral values of k for which the system is equals to pi square k, and tan inverse x plus cos inverse y equal to pi by 2. Should we solve this? Yes, so please pay attention. Tan inverse x bracket square plus cos inverse y. Arc cos y is cos inverse y. Arc tan x is tan inverse x bracket square. That is tan inverse x. Now you all know the principal value branch of tan inverse x. It is from how much? Minus pi by 2 to plus pi by 2. Yes. If you square them, the range would be from 0 to pi square by 4. Do you agree? Now you cannot say that sir minus pi by 2 is a square kariya, plus pi by 2 is a square kariya. The range is from pi square by 4 to pi square by 4. It will make no sense. From minus pi by 2 plus pi by 2, 0 also is included. The square of 0 is 0. So range couldn't go to from 0 to pi square by 4. Yes or no? So tan inverse x bracket square ची range दिले from 0 to pi square by 4. Cos inverse y bracket square ची range दिले तर cos inverse y ची आपल्याला माहित आहे 0 to pi असते ना. इथं तुम्ही स्क्वेअर करू शकता. 0 चा स्क्वेअर 0, pi चा स्क्वेअर pi square. So the values would be ranging from 0 to pi square. Do you agree with these first two questions? First two equations? Do you all agree with it? Now simply when you are adding them, when you add them, the total range of this addition would be 0 to 5 pi square by 4. Yes or no? Pi square by 4 plus pi square will be 5 pi square by 4. Zero less than equal to, they should have mentioned this here. I would say 0 pi square by 4 less than equal to this, less than equal to 5 pi square by 4. Yes or no? 0 can be written as 0 pi square by 4 less than equal to 5 pi square by 4. But the value of this has been given in the question as pi square k. Is it? What the question is given? Pi square k. Yes or no? So what does this mean? This value is going to range from 0 pi square by 4 and 5 pi square by 4. Yes. If I cancel pi square from all the sides, does it mean that 0 less than equal to k less than equal to 5 by 4? Please tell me. If I just eliminate pi square from all the three terms, does that mean 0 less than equal to k less than equal to 5 by 4? So k should be less than equal to 5 by 4. So determine the integral values of k. Which are the possible integral values of k? Please tell me. 5 upon 4 will be 1.25. So what is the possible integral value of k? You can see this here. For this again you have to go for the second condition also. This is the only condition which you have got, and from this the integral values of k which would be possible are 0 and 1. Yes. Integral condition of k which are possible are 0 and 1. Now if you take the original equation, like the equation which we solved for example number 30, will you be able to form this kind of quadratic equation? Will this kind of quadratic equation be formed? Yes, please tell me. It will be formed, yes. So if you solve this quadratic equation, when you get the quadratic equation, should you fish for the discriminant to be greater than equal to 0? to get the real roots, what should the discriminant be? Should that be greater than or equal to 0? If you're getting this quadratic equation, how did you get this quadratic equation? Simply, tan inverse x is replaced by pi by 2 minus cos inverse y bracket square plus cos inverse y bracket square equal to pi square k. Now, if you solve this quadratic equation, whatever quadratic equation you get, it should get, or it should have roots. It should have real roots. To have real roots, the discriminant should be either 0 or greater than 0. So I have taken the condition as greater than or equal to 0. So if you solve this, you can see pi square getting cancelled from everywhere. The value condition of k which you have got is greater than or equal to 1 by 8. That is greater than or equal to 0.125. And in the first condition, you got k as 0 less than or equal to k less than or equal to 1.25. So from this both condition, what do you understand? K should be not 0, k should be only 1. Yes or no? K shouldn't be 0, k should take the value 1. Yes, from both the conditions, what did you understand? One from the perspective of the principal value branch, and the second from the perspective of the quadratic equation, discriminant of the quadratic equation. We got two conditions for the value of k. One was from 0 to 1.25, and the second one was less than or equal to 0.125. Sorry, greater than or equal to 0.125. And k is an integral value. So the only option which is left with is k equals to 1. And using k equals to 1 and then using the formula method, you will get the solution. Straight away, you can use k equal to 1, put k as 1, and use this formula method. Minus b plus minus under root b square minus 4ac upon 2a. You will get two values for cos inverse y. As cos inverse y is lying between 0 to pi, check which value to consider and which to neglect. And accordingly, you will get the value for tan inverse x. And therefore, you will get the value for x. I'll repeat this solution once again. Vishwas, pay attention. This was the equation given in the question. And this was the condition which was given. And find all the solutions they have asked us. So basically, they have given an additional condition that k is an integer. Now looking at this equation and looking at this condition, first of all, what we need to do is, we all know arc tan x, that is tan inverse x, bracket square, its values would be ranging from 0 to pi square by 4. Because tan inverse x ranges from minus pi by 2 to plus pi by 2. So if you square them, tan inverse x ranges from minus pi by 2 to plus pi by 2, including 0. So if you square them, it will be pi square by 4, from 0 to pi square by 4. Yes, all of you? Do you agree with this? Tan inverse x bracket square will be ranging from 0 to pi square by 4. Cos inverse y bracket square will be ranging from. Now you all know the principal value branch for cos inverse is 0 to pi. So if you square them, it will be ranging from 0 square to pi square. That is 0 to pi square. 0 to pi square. Got it, all of you? Now, if you just add these two equations, what is going to happen? 0 plus 0 is going to remain 0. Tan inverse x bracket square plus cos inverse y bracket square less than or equal to pi square by 4 plus pi square will be 5 pi square by 4. Yes or no? But the value of this is given as pi square k. So will the condition look like 0 less than or equal to pi square k less than or equal to 5 pi square by 4? Yes or no? Will the condition look like this? Because the middle value as given in the question is pi square k. So if I replace this by pi square k, will I get the condition as 0 less than or equal to pi square k less than or equal to 5 pi square by 4? Can I write 0 as 0 pi square? Can I write 0 as 0 pi square? So if I just cancel pi square from all the three terms, will the ranges of 0 will be 0 less than equal to k less than equal to 5 by 4, that is 1.25. So which are the possible integers here? K equals to 0 and 1. From the first condition, what are the possible integers we got? Between this range, what are the possible integers? Because k is an integral value. What are the possible integers? 0 and 1. Did you understand this? Coming to the second condition. In the second condition, what has happened here? We have tried to solve the quadratic equation. How did we solve the quadratic equation? The same question which we did in the example number 30. The addition of their squares is pi square k. So tan inverse x is replaced by pi by 2 minus cos inverse y. Or you can go like the last question also. A square plus b square can be written as a plus b bracket square minus 2ab equal to pi square k. You can do this as well. And a plus b is nothing but pi by 2. You can see here tan inverse x plus cos inverse y is pi by 2. So from this, you are going to get a quadratic equation. Yes or no? You will get a quadratic equation. And from that quadratic equation, you should say that the discriminant should be greater than equal to 0. The discriminant should be greater than equal to 0. And if you solve that condition, if you solve this condition, the value of k which you will get is greater than equal to 1 by 8. Now you all please tell me which integer is possible here. Greater than equal to 0.125. That is k equal to 1, 2, 3, 4 and so on up to infinity. Second condition tells us that k can take any value greater than equal to 1, 2, 3, 4 or any integral value. Now from both the condition, if we consider which is the common value that satisfies both the condition, correct? It is k equals to 1. So just use k equals to 1 and solve the rest of the question. As simple as that. Got it, all of you? I hope you have understood this. So you can look at this question. Tan inverse 4 upon 1 plus 3 into 4. Tan inverse 6 upon 1 plus 8 into 9. Plus tan inverse 8 upon 1 plus 15 into 16 up to n terms. Could you think of a general term looking at all these terms? 4 upon 1 plus 3 into 4. 6 upon 1 plus 8 into 9. Eight upon 1 plus 15 into 16 and so on. Could you think of any general term regarding these terms? Because here is where the solution starts. You cannot straight away scribble some first step. You have to think upon it. Think upon this, think upon this. What is the common pattern you can see in all these cases? That should satisfy the first, second, and the third. 3, 4, 8, 6, 15, 18. Because one thing I can see here is these are two consecutive numbers. So that one pattern is going to remain common. But what about the numerator? How is it associated with the denominator? Now you might say, sir, the second number's half is the first number in the numerator. But that is not the case in the first and the second. So we have to think about some common pattern which is to be followed everywhere. Think of it. Yes. One more thing I can notice here is 4, 9, 16, all are perfect square. Yes or no? So for time being, let me write 4 as 2 square. Let me write 9 as 3 square. Let me write 16 as 4 square. Is it okay for you people? Yes. Now you will start to get the hint. Please pay attention. Now I can see that in the denominator is 2 square, but the double of 2 is 4 in the numerator. In the denominator is 3 square, the double of 3 is 6 in the numerator. Denominator is 4 square and the double of 4 is 8 in the numerator. And they are consecutive. 2, 3, 4. So you can predict the next term as well. And what about this 15, 3 and 8? These are nothing but 2 square minus 1, 3 square minus 1 and 4 square minus 1. If you all agree. Because it is only one less than the number. They are consecutive numbers, no? As I already told you. So if I have to find the fourth term, will that be, I'll start with the clue I have. 2 square is done, 3 square is done, 4 square is done. So 5 square into 5 square minus 1, that will be 24. And double of 5 is 10. Will this be the case? All of you? So this is the pattern which you have to understand from the question. Only then it is possible to solve such kind of questions. Do not look at the solution. Just do not focus on this. This is going to paralyze you. Try to understand what the pattern is. Once you understand the pattern, the rest of the part is simple. I'll tell you how. Now you can generalize this in the terms of n. Just pay attention now. The first term was tan inverse 4 upon 1 plus 3 into 4 plus tan inverse 6 upon 1 plus 8 into 9 plus tan inverse 8 upon 1 plus 15 into 16 up to n terms. Yes? Now what did I understand this? Now 4 is nothing but twice of 2 and 1 plus 3 is 2 square minus 1 and 4 is 2 square. Yes, do you all agree? In the same way, 6 is nothing but twice of 3 8 is 3 square minus 1 and 9 is 3 square. Will this series go on continuing up to n terms? Because in the first term there is 2, in the second term there is 3. So in the nth term there is going to be n minus 1. Yes or no? Yes. Because in the first term there is twice of 2, square of 2 minus 1 and square of 2. In the second term, sorry, I should do n plus 1. Sorry. In the first term there is 2. In the second term there is 3. So in the nth term there is going to be n plus 1. One step ahead, no? In the first term, what can you see? 2 plays a major role. In the second term, who is playing a major role? 3 is playing a major role. So in the nth term, who is going to play the major role? N plus 1 is going to play the major role. Do you understand this? This is the most important thing which you have to understand. The rest of the part is easy. Finding the general term is all important here. Now you can tell them that this series is nothing but summation of tan inverse of 2 into n plus 1 upon 1 plus n plus 1 bracket square minus 1 into n plus 1. And n runs from, or you can say r runs from 1 to n. You can replace this by r and you can say that r runs from 1 to n. Because if you put r as 1, you will get the first term. Yes or no? Yes, all of you? 2 into r plus 1 upon 1 plus r plus 1 bracket square minus 1 into r plus 1. This is something which you have been already trained in the lesson sequence and series. So that is going to help you. So I'll just write the general term now. The general term is summation. R runs from 1 to n. Tan inverse of 2 into r plus 1 upon 1 plus r plus 1 bracket square minus 1 into r plus 1 bracket square. Now you all tell me, simple question I would want to ask you now. You have learned this formula tan inverse of x minus y upon 1 plus xy. Have you? So could you relate these two forms and tell me how or what could be the value of x and y? X and y should be such that their product should be seen here and their subtraction should be 2 into r plus. Yeah, this is equals to tan inverse x minus tan inverse y. That should be our next step. But how do you split this? 2 into r plus 1 upon 1 plus r plus 1 bracket square minus 1 into r plus 1 bracket square. Please join again. If the meeting gets ended, please join once again. Tell me what can we do here? Think about it. Join again.